Oh, I haven't tested this yet to make sure it's working. Yeah, there it is. All right, so today is finishing off percents and percent change. And the mistakes that people make with percent change. Everybody makes, which is kind of funny, but I'm going to try to get rid of that misconception. So let's talk about percents for a second. I got to flip my pages. I think the last example I gave was the high school group smoking, if I remember right. All right, so another way of looking at percents, instead of as a proportion, if we're just talking about percents as a ratio rather than a proportion, we can change this formula around a bit. Generally, if you're trying to solve for percents, you're trying to solve for x. So if I solve for x, all I have to do is multiply both sides by 100. Get rid of the 100 on that side. So x is going to equal the fraction times 100. And this will be written as a percent. So when I put percents in parentheses, it's not that that number is going to be calculated as a percent. It's just whatever the answer is going to be turned into a percent. So if I have something like 4 out of 9 doctors, you've seen this before, right? Blah, 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 approve of Crest or whatever.
It's never 9 out of 9, is it?
No, it never is. Have you ever seen the commercial where that guy got hit by something and passed out and that's why he couldn't get to vote? What was it? It was Geico or something. They do weird commercials. So in this case, if I want to find the percent, I could just go 4 divided by 9, multiply that by 100, and write the symbol percent after it. So it's 4 divided by 9. Oh, yeah, you have calculators.
0.44444444
forever, right? So this would be, wait a minute. Did you multiply by 100?
times 100
Yeah, that would help.
would be.
Don't do minor calculations. Do the calculation. 4 divided by 9 times 100, it equals. Don't do sub-calculations. This should turn into 44.4%. So you could say 4 out of 9 doctors, but you also could say 44.4% of the doctors agree with whatever that's being said. So that just makes things a little bit quicker than trying to do a proportionate style. I think. All right, the next thing up, let's look at tables. Table depth.
What's that one called?
It's just percent. It's changing a ratio into a percent. 4 out of 9 is a ratio, and 44.4 is a percent. So you're taking a ratio and changing it into a percent. You can always do that. We're going to do it again with this thing too. Let's say we have degrees. It's not horrible, it's just got a bunch of numbers in it. So let's say this is 17, 38, 51. This is 24, 45, and 70. Okay. Whenever you're given a table like this, and we can interpret it pretty easily, men who have high school degrees, how many of them are there?
17.
Women that have 2-year degrees?
45.
45, and so forth and so on. So the table's pretty understandable for most people.
What I didn't understand on the test thing was, like you just said, how many men have high school degrees? Don't you have to add the high school degrees to the 2-year degrees to the 4-year?
Everybody, yeah. But it depends on how the question is phrased. You have to be careful of that. We'll get to that in a second. But when you see this table, the first thing you do is don't read the questions. You haven't really finished the table yet. I highly suggest you come up with totals. So in other words, how many people have high school degrees rather than men and women? So you have to take the 17 and 24 and add them together. So that's what?
41.
41. And 2-year degree total?
83.
83. 4-year degree total?
121.
121. While you're at it, total the other way. Or not diagonally, horizontally.
106.
So 17, 38, and 51 would tell you how many men are in this
106.
group. 106. And 24, 45, 70.
139.
And to make sure you did this right, I highly suggest you add up the bottom numbers, you add up the side numbers, and make sure those two numbers come out exactly the same. Otherwise, you did something wrong. It should be 245.
Yes.
245. So we can think of this as a room of people, 245 people in this big room. Maybe it's like a high school reunion or whatever. And they separated them out into high school for 2-year degree, 4-year, I usually call it 4 or greater degree, graduate school, all that fun stuff. So some of the little questions that you can ask. Let's use this one. 1. What percent of group has a 2-year degree? Do not answer these questions too quickly. Some of them are real easy, but some of them are a little bit subtle in how they want you to answer. So you always want to find two things: the main group, the subgroup. Now this one, it's pretty obvious what the main group is. The main group is the whole group. All right. So the subgroup would be considered the 2-year degrees. So your main group is usually talked about first, and the subgroup is usually talked about second, but that's not always true. So you always have to think, what group are they really talking about, and then what proportion of it inside of that are you talking about? So if we're talking about the main group, that's 245 people, right? So that's going to be your denominator. Your main group always goes in the bottom. And then the top of your ratio is going to be your subgroup, the smaller portion of that group. Can the subgroup and the main group be exactly the same?
Not.
No.
Why not?
Oh, subgroup.
What is the percentage of people that are in this room? 100%. Yeah, I mean, but it's kind of a silly question to ask. What would be the number on the top? Well, what we're interested in is 2-year degrees. So it's not men 2-year degrees or women 2-year degrees. It is 2-year degrees, which is 83. And then we can use the formula to the left to find out the percent. So it's 83 divided by 245 times 100. Change it to a percent. What's it equal to? I don't even think I wrote the answer down.
The answer is 33.87755,102.
Do you think I'm done?
Yes.
And do you think I want that many decibels?
30. Right, that's it.
30 point.
33.
30. You didn't hear me, did
You're too loud. It just deafened me. 33.9. What's after the 9? I'm just curious.
Percent.
It's a
No.
Oh, it's
Percent.
8.7.
8.7. Alright, so you already rounded it. 33.9% of this group has 2-year degrees. Simple.
Yeah.
My eardrum is still ringing.
That's because he's got his toboggan pulled down over his ears. And
He's probably playing music and he's talking. You know those people with the headphones that talk really loud. 2. Gosh, I could hope I can write this low. You don't get to answer anymore. What? I like hearing. I'm getting old. What percent of this group, I should have put, is a woman with a 4-year degree? So when we separate this into subgroup and main group, the first thing we really want to find is the main group. What is the main group here?
everybody.
Well, if you said woman is the main one of the women.
There's a lot of words here. What percent of the group is a woman with a 4-year degree?
The group is 245.
Is it 45?
No.
Like 83?
It would be
139.
139.
139 is the main for women.
What's the main group?
The women.
The women?
The whole group.
Oh, 245.
See, it has group, it has 4-year degree, and it has women. So you're starting to think, oh dear, it must be a subgroup of women or a subgroup of 4-year degree. But the question is asking what percent of the group is a woman with a 4-year degree.
Oh, okay.
Then all you're really looking at is the women with a 4-year degree, which is
70.
that's your subgroup. But your main group is the whole group. So this would be 70 out of 245, times it by 100, change it into a percent,
28.6.
28.6%. The calculation is not the hard part. The figuring out which numbers you really should use is the hard part. Next question. 3. What percent of women have a 4-year degree? Sounds like the same question.
Uh-huh.
Yeah, but the main group is not 245 anymore. It's
Yeah, the main group is not the group anymore. What's the main group now?
100.
Is it the women or the 4-year degree?
It's the women. It's the
It's
women.
So when I talk about sub and main, the main group is
The women.
the women. So how many women are we talking about?
139.
139 women. And out of the women, you want to talk about the ones that have 4-year degrees, which is also same as that one down there, 70. So words are important, and how you interpret them is also really important. So take that, times it by 100, change it to a percent, and you get
50.4.
50.4%. So as long as you keep your head about you, these questions shouldn't cause any difficulty. You just got to be very careful how you interpret them. Last one here. 4. What percent of high school degrees? Now, when this says high school degrees, it's not everybody. In other words, the highest degree you're getting is a high school degree. If you have a 2-year degree, you don't get to belong to that group, and now you're in 2-year degree, and so forth and so on. All right, so what percent of high school degrees what percent of the high school degrees in this group are men? So what's your main group?
High school.
High school. So when we talk about the main group, we're talking about the high school people. What's the subgroup?
Men.
The men. So the main group has how many in it?
17.
41. The main group is high school degrees. And the total of high school degrees is 41. Now the subgroup is men. So do you use 106?
No.
It wouldn't make any sense. If you put 106 over 41, that's bigger than 100%. You ain't gonna get that. So when you talk about the 41, you can't talk about anybody but the two numbers you added up. So what one relates to men?
17.
17. So out of the 41, 17 of them have high school degrees. Maximum of the high school degree. Multiply that by 100, change it to a percent. What's it equal?
41.5.
41.5? 41.5%.
So every time we round, we just start after the 10th place.
Most questions, even if they don't say round to the nearest 10th, round to the nearest 10th.
Oh, okay.
If it's money, round to 2 decimal places, but pretty much everything else, 10th. Unless it says like round to the nearest whole or round to the nearest hundredth.
Oh.
Some questions I forgot to put in round to the nearest 10th. But I try to edit them as I go. All right, so that's percent. Where's my good eraser? Get rid of all of that. And tabled values. kind of conquer two at once. Let's deal with the hard stuff then. And you're not going to like what I do. Sorry. But I'm going to do it. So try not to complain too much as I go through this. Let me back up. Subtopics before we get to percent change. Absolute change. When we talk about percent change, that's called relative change, and we'll get to that in a second. Absolute change is pretty simplistic. The formula for it is new minus old. Pretty simple formula. It's funny how people screw it up. Usually when things are really simple, that's usually when people screw things up. When things are really hard, they focus a little bit more and actually generally get it right more often. So for example, seriously, it's weird. Unemployment. This year is around 5.6%, which is a change of 2.7 points from last year. What's a point? Nope.
1.0.
Have you ever heard of getting a mortgage and paying points on your mortgage?
No.
Things you have to learn. Points are related to percent. So when I say 2.7 points, it is actually 2.7%, but it is an absolute change of a percent. So when you see this word, this is an absolute change. The word points. Basically, if you have a mortgage at 4.5% and you're going to pay 2 points on your mortgage, you have to pay 2% of the cost of the house, basically. But you also can use points to say a change from 5.6. So if unemployment this year is 5.6, which is a change of 2.7 points, absolutely, from last year, the question is,
8.3%.
what was last year's?
8.3%.
And how'd you figure that out?
Was
So you add 2.7 to 5.6,
Yes.
and I'll say, you got it wrong.
What?
Isn't that great? I
Yeah.
told you, this is the one that people screw up.
Because it's not saying whether
Hold on,
it's
hold on,
changed.
hold on, hold on.
I know why.
Don't depend on just throwing numbers in your head and writing them down. Well, you might be actually right, so be quiet for a second.
We don't, the question doesn't say if it's.
Which way it goes, up or down.
Oh, it doesn't?
It just say
Are you
change.
sure?
It say change. It can say positive
Hold
or
on.
negative.
So the formula is new, oh, this marker stinks, minus old is equal to the change, right? Which one do I know, the new or the old?
The new
The new
one.
The new one. So this becomes 5.6% minus the old one. I have no idea what it is, but I'll write X%. And the change is 2.7%. I highly suggest you do this because sometimes it flips order and you have to be really careful. People will still add those together. If it was a percent, the change actually went up. So like unemployment was at 5% and then it went up to 6%. This number would be -1. So 2.7, because then it would be a decrease according to what it was before. So here,
So,
new minus old. Yeah, this one.
subtract.
So to find x, you could subtract 5.6, but I'd rather use a neat little trick. Let my brain get straight because you all got me messed up in my head.
Subtract.
You said 8.3 and now it's stuck in my head. It was 8.3 and I know it's not 8.3.
Subtract.
So the trick is this. This one's negative and this one's positive, and you're trying to solve for x.
Which one's negative?
That X.
My big body's in the way. So what you can do is, if I move the x to the other side, what does it become?
Positive.
If I make the 2.7 go the other way, it
Becomes
makes it.
negative.
So I can just take these two and
Flip
switch
flop.
them. Yeah, do a flip flop. So this is 5.6. Oh, all right, throw this marker. 5.6 minus 2.7
2.9.
is equal to
2.9%.
the actual answer.
And I was wrong.
And you're wrong. Because the number on that thing is positive, that means your percentage actually went up. If it was negative, your percent would go down. So this becomes, what is it? 2.9? 2.9%. So last year, the unemployment would have been 2.9. Is this realistic?
What?
No, because unemployment last year was actually higher than it is this year.
So you still gotta write the x that way.
Yeah.
No, but I'm just emphasizing that we're talking about x as a percent, but x usually for us is going to be a percent, but as a whole number, not a decimal value. That's where people get confused.
Oh, okay.
So yeah, you could just write x is equal to 2.9%. So be careful with this absolute change. It's not always obvious what the answer is, even though you think you know it. How about George? I love George.
See, I was wrong. See, you don't get that out of me often.
I like people having wrong answers. It means I'm teaching you something. If you always got the right answer, what's the point of being in the class?
To get a grade.
To get a grade. George made $22,500 this year, a change from last year of negative $12,000. How much did he make last year?
I know that.
And again, when you think about things, you usually think about people getting raises. But when the economy went down and people lost their jobs, they actually took major pay cuts to get another job. So when we set this up, we're going, this is a bad marker. When we set this up, we'll go new minus old equals change. And what's the new value here?
22.
The 22,500. The old value?
X
Negative 12,000.
You don't. The
X,
old number.
X percent.
Oh, it's
How
How
over.
much did he make
That's
last
why-
year?
12,000.
X.
X. I have no clue how much he made
Oh,
last
that's
year. I just know that it was a $12,000 change. Now the change is negative 12,000. I thought I told you not to answer me anymore. Same trick applies. Take the X and the 1200 and switch them.
Flip flop.
No. This one's
Got it.
negative now.
Oh,
You
it's
can't just flip flop. So you're kind of stuck going the other way. Subtract 22,500 from each side. To get the X by itself, how do I write it?
Minus X equals
Oh,
minus
it's not minus X.
negative X.
Negative X is equal to
Negative
negative.
30.
No, wait, wait, wait.
Oh.
Shh, shh, shh.
Ah, he's talking about.
Mouthy. So then X is going to equal positive 34,500. So how much he made last year was $34,500. So what you expect is not always what happens. So don't be guessing at these things. Set up a
So-
formula, plug your stuff in, solve. Cross that out. Relative. Relative change. It takes your absolute change and changes it into a proportion, which will change it into a percent. So to change it into a proportion, you go new minus old, which is your absolute change, and you divide by what it's being changed from, which is
Oh.
the old. You times it by 100, you change it to a percent, and this is going to equal x. Now x is written as a percent, so I'll also put over here percent. So if you do this calculation and you end up with 15, it's 15% automatically. So eventually I'm going to drop the percent next to the x, and x is always going to be the whole number percent, not the decimal value of a percent. ECC had a student population of 2238 in 2012 and 1734 in 2014. What was the percent change, relative change, in the student population? So when we do this by the formula,
My English teacher told us it was 200 less people.
what? Oh, compared to last year, yeah.
Yeah.
Compared to last year. I'm just making up numbers though. So when I read this problem, what number associates with new?
2238.
2238.
1734.
Yeah,
Why?
12.
Because it's in
That's the year.
2014. It's the newest value that I have. The old value is back in 2012. So when I put in for new, it's 1734. The old value is 2238. And by the way, if you get those two backwards, not only is your sign going to be wrong, but you're also going to choose the wrong number to go in the denominator. Because it's new minus old, and then that number just repeats itself in the bottom. So that's why you have to be a little cautious with this stuff. In the bottom goes the old value, 2238. Just throwing numbers at this is not going to help you. You have to know what number really belongs in what position. Times it by 100. Change it to a percent. What was our, obviously, decrease?
22.5.
22.5, so negative 22.5%, but you can also write it as 22.5% decrease. In Moodle, I highly suggest you write it the first way,
What are you talking about?
because Moodle does not like words like decrease. If you write decrease, it will mark it wrong. So just do negative 22.5% and be done with it. Sometimes a simple percent is given to you. Sometimes you actually have to type it in. If it says and unit, type it in. That's not that bad, right? Pretty easy. Let's get to the hard part. That's just finding the percent change. If you think of this algebraically, there's three variables. There's the new variable, there's the old variable, and there's the answer variable, which is known as x. So that means I can solve for any one of the three, given the other two. So here I gave you new and old, and we came up with x. But I also could give you x and come up with either new or older. Those are the harder ones. Those are the ones people do not like. And then they try to do shortcuts to them, and it really messes things up.
The one you're getting ready to do now.
Yeah. For instance,
So it always gonna have that relative change in it for you to know the difference, right?
well, you got to be careful when it says absolute change or percent change or relative change. If it's absolute change, it's just a subtraction.
Oh, okay.
If it's relative or percent change, it's that formula. It's that formula. I always hate this word. How do you spell salary?
A-R-Y.
A-R-Y. Salary. Whatever, salary. Mike got a raise of 5% on his salary. This year, or I should say last year. Last year, he made $22,500. How much will he make this year after the raise? Okay. Oh, this marker is not doing very well.
It works.
the screen over there. All right, so what do I have? Well, I got this 5% raise. That is a percent change. When you get a raise, you don't just get 5% of your salary. That would be a pay decrease, big time. So a raise of 5% is a percent change. And you have this number over here. What does this number represent? The old. This is what he used to make. What we were curious about is what he makes now. All right, so we set it up. New minus old over old times 100, change it to a percent, and this will equal X. Okay. The new value, do I know it?
No.
No, so I'll leave that alone. New. Minus the old value,
22,500.
the 22,500, divided by 22,500, times 100 is equal to X. Oh,
5.
X is
5.
5. If you want, you can write the percent. If you do write the percent, leave that one. If you don't write the percent, drop that one. In other words, you either make them both percents or drop it. I highly suggest you drop both of them. So this is literally 5%, but you just want the 5, so I'm not going to leave this percent symbol in the formula
Oh,
and just make it a numeric 5. All right, what I want to get is to the new. There's a lot of stuff attached to the new number. So what would you do first? That's an old-time movie. To solve for new, what would you get rid of first? What's kind of in the way of getting to the new? Well, the 22,500 is, and this 22,500, and also, out of those three, which one would you move first?
22.
Notice my marker is not moving from this position. Move the 100 first. To move the 22,500 is messy. It's easier just to move the 100. And also it leads you into a shortcut that I might talk about. Probably not. So divide both sides by 100. When you take 5 and divide it by 100, what are you really doing?
5%.
You're changing 5% into a decimal form of the percent. That would be 0.05. All right, so after you divide by 100, these would cancel out, right? That's nice. And you're left with new minus 22,500 over 22,500 is equal to 0.05. Okay, that gets rid of the 100 and it breaks down a little bit wrong. Out of all the pieces left on the left, which one can you move first?
The bottom.
The bottom. How do I get rid of 22,500 in the bottom?
Multiply.
Multiply by it. So I'm going to multiply both sides by 22,500, the entire side, and multiply this side by also 22,500. Okay. So these 22,500s are going to cancel, turn into a big fat 1. On the other side, if you look at it right, this is the decimal percentage of 5, 0.05, and you're taking that and multiplying it by 22,500. In other words, 5% of 22,500. So it's kind of leaning into something that you should have done a long time ago. We'll get there though. Now we're down to new minus 22,500 is equal to, what's 5% of 22,500?
11.5.
11,
25.
$11.25?
1,100.
Oh, 1,125. Okay. Then what would you do? Oh, by the way, that represents his raise.
And
He's making 1,125 more than, I said it the wrong way, 1,125 more than last year.
Add 22.
Add 2,200 across, and you get
23,625.
23,625. So his new salary for this year is going to be 23,625. Not bad. Dollars.
I have a comment.
Go for it.
Just
The way I was taught,
I know.
you just take 22,500.
I know. There's a reason I'm doing this.
Okay.
There's a reason I'm doing this. Why? Because of mistakes. And I know what mistakes are going to happen eventually. If that's the only style you know how to solve these, half the problems I have you're going to get wrong.
Half of them you'll get right. The ones that are this, you'll get right. But the ones where you're trying to find old, you're going to get every single one of those wrong. And guess which one I asked more of?
The old.
The old. Why? Because I'm just so crazy, I guess. Now, technically, your old method is this. It's take 5% of the 22,500, take that answer and add it to your original salary. That's the old way. And that's a perfectly fine way of doing it. So you change your percent to a decimal. You take your percent as a decimal, you multiply by your value. You take that answer, which is your increase, and you add it back to your salary. That'll get you to... Alright, so if we plug this into our formula, mean minus old over old times 100 is equal to X percent. Now the 125, what is it, new or old? It's definitely old. It's when you originally bought your house, it's going to either increase or decrease in value. So the new value is what I'm looking for. The old value is 125,000, and you divide by that same number. These two numbers are always the same, so don't make them different. Whatever is in that second position has to go in the bottom. One thing I forgot to tell you, if this is all numbers, you have to do your subtraction on the top first to find the absolute change. Take that answer and divide by the bottom. If you just type it into your calculator in one line, it actually gives you the wrong answer. So be careful of that. Times 100 is equal to 17. And if you just do exactly the same steps, you would first divide both sides by 100. Change that into 0.17. And what?
Is it a new number for the bottom, or you just forgot to do zero?
Yep. Most common mistake ever.
It's what?
Leaving a zero off or putting a zero on. 125,000 is equal to 0.17. Then you multiply both sides by
125,000.
125. Make sure you get all three zeros. And this answer will tell you how much your house has actually increased in value, the absolute change.
You say you multiply that or divide?
Multiply. Because if you multiply both sides by the 125,000, they're going to cancel on this side, and then it gets introduced on the right-hand side. Always multiply because it's in the bottom. So this gives you new minus 125,000 is equal to how much?
212.50.
212.50, better known as 21,250.
I'm supposed to be quiet.
Yes, you are. And the last step, of course, is to add the $125,000. So the new value on the house should be in dollars.
146,200.
Tone it down.
Put it as a conversational tone rather than an aggressive, I'm going to kill you tone.
That's confidence.
That's confidence. I feel dangerous. 146.
250.
250. Yeah. You're going to add this 125,000 across to both sides. So that it cancels out on the left and gets introduced on the right. So that's how finding new works. There's a better way, even better than some of the ways that were shortcuts around the room. That's what's next. Did I say you were going to like it? No. So, let's see. How about this? Oh, how should I do this? Let's talk about tax. I'm going to talk about tax in a weird way. I'm going to do it two different ways. I'm going to find the final cost of an item with tax, and then I'm going to go backwards and start with the final cost of after tax and go back to the shelf price, the original price. So when we're talking about tax, let's say there's a 7% tax, sales tax. You purchase $250 worth of stuff. So when you go to the cash registers, they punch in the numbers, and no one ever does these calculations anymore. They're done by the computers so that mistakes aren't made. So we can do this with new minus old. Over old times 100 is equal to x. This thing is screwing up royally.
The sales tax is going to, you can take 7.
It's 7%, right?
Oh, no, I'm saying the way that sales tax part's going to be right under the tax. No, I'm just saying how you're supposed to write it.
Oh, well, I just forgot the word sales, so I just threw it above.
Oh, okay, that's all it is.
Yeah, 7% sales tax. Do I know the new value? No. That'll be the value with tax. Do I know the old value?
Yeah.
$250 divided by $250 times 100 is equal to 7. Just 7. Because we're dropping the percents from both sides of this weird formula. So again, the same steps are going to apply. Divide by 100. Excuse me. We're going to get new minus 250 divided by 250 is equal to 0.07. When you take a decimal or a number divided by 100, you move the decimal 2 places to the left. The next step would be to multiply by 250. So you're going to get new minus 250 is equal to 0.07 times 250. Let me bring this up here. What's 7% of 250?
17.
So you get new minus 250, how much? 17.5?
Mm-hmm.
Since we're talking about money though, 1750. And then add the 250 across. So 1750, how would you label this number? What does 1750 represent for this
Money.
question?
Increase.
The tax.
The tax, literally just the tax. It's not the percent tax, it is the tax on these items. $17.50. So the next step would be to add the 250, and that would be our final cost at the cash register. So the total price would be $267.50. I love when sales are, oh, you don't have to pay sales tax, or we'll pay the sales tax for you. 7% off. Or something like that. So that's how you can use this to find tax. The other idea is sales or discounts. And again, I'm just going to go forward first. The next 2 examples I'll go backwards with them. But backwards gets very tricky, and most people do the backwards version wrong. So let's say there's a 30% off sale. It's also known as a 30% discount. 30% discount. You gonna live? No. Let's say the original cost is $250. What is sale price? What is the sale price? Now this is the original cost and sale price. It has nothing to do with tax. If you wanted to find the tax on it, you'd have to come back over and mess around over here. Of course, there's shortcuts. So new minus old over old times 100 equals x. Old percent change formula. All right. Do I know the new value?
No.
No. Do I know the old value? Yes. 250. Divide both sides by 250. Times 100. And it's equal to x. Oh, not x. It's not x. What is it?
Dollar sign.
No, it's not x or a dollar.
30.
Now is it 30?
Oh, point 30.
No, it's not 0.30. Is it 30?
It's 30.
If it's 30, it would be like a sales tax, and sales tax does what to your price?
Increase.
Adds it up. So if I want this thing to go the right direction, I better make that 30
A negative.
negative. So this turns into negative 30. Discounts are going to be negative percents. Taxes and increases are always going to be positive percents. So this number pretty much tells you if it's going up or going down. Since it's negative, it's going down. All right, first step of solving, divide by 100. So you get new minus 250 divided by 250 is equal to negative 0.3. I like keeping the 0, but you don't have to. Negative 0.30. All right, next step would be
Multiply.
multiply by the 250 in the denominator. So you get new minus 250 is equal to negative 0.30 times 250. When you multiply 250 on the left, they cancel. It introduces itself on the right. What's 30% of 250?
75.
$35?
75.
75. Yes. Okay. So this would be new minus 250 is equal to negative 75. What does the negative 75 represent?
The discount.
The discount. So you're saving yourself
$75.
75 bucks. Add the 250 across, and the new is equal to
175.
175. And don't forget
Dollar sign.
dollar sign. So your sale price is $175. Original cost is $250. Alright. And again, there's easier ways of doing that one.
Yes.
That's horrible. That's streaked black all the way across the board. Oh, that's my gold eraser, that's why. That's worse. There is an easier way of doing this, of course. If you look at it step by step, this step to here, you're changing your decimal into your percent into a decimal. This step from here to here, you're taking your original cost and multiplying by the percent. This step from here to, well, the end, is you add that number back to your original cost. So there's shortcuts involved, but this describes it actually a little bit better than the shortcut does. So what's the hard way? Well, the hard way is going backwards. And going backwards, we're going to be talking about
Grandma.
the problem with backwards is this. If I have a new value of 5, and I have it as old over old times 100 is equal to 15. So in other words, the percent change from some number to 5 was a 15% increase. It's a 15% increase. The problem with this is we're solving for old, but old lands in 2 places, in the top and the bottom, which makes it very difficult to solve for. So I'm going to change gears and go straight algebra with this thing. Remember algebra? Don't you just love algebra? Bunches of letters. The problem with old is I want to represent it with a single letter, but if I represent it with this, it looks like 0. And so therefore I change it into grandma. Grandma is old. So it becomes G. Dear Lord. So I'm going to let N be new. I'm going to let G be old, divided by old, times 100 is equal to X. So N represents new, G represents grandma, and grandma is old. So it's still new minus old over old. But I like G better than 0, because 0 just looks like a number, the O in old. All right, I need to solve for G. It's better without numbers, trust me. If I put numbers in here, your focus is on the numbers and not on the G, which is more important. All right, if I'm solving for G, what would be your first step?
Divide both sides by 100.
Yeah, might as well start off exactly the same as we did over there. Divide both sides by 100. So you get n minus g over g times 100, I got rid of the 100, is equal to x over 100. Okay, that's your first step. Do you remember solving linear equations, the steps involved? You know, get rid of parentheses. If you can, get rid of fractions. Try to get rid of fractions as quickly as possible because most people are not really good with fractions. And the way to get rid of fractions is the common denominator. Well, in this case, the common denominator is 100 and g. So I'm going to multiply both sides by 100g. So if I multiply this side by 100g, and I multiply this side by 100g, if you want over 1, you know, in case you get confused by where that 100g lands in the top or the bottom, what happens to the g's on the left-hand side? They're going to cancel. What's left over? 100. Oh, can I back up one step?
Yes.
I mean, I could multiply by 100g, but I really don't want to. I want to leave it with the x. And there's a reason. X is a percent. If I divide by 100, it changes it to a decimal. I really want that piece there. So let me get rid of the 100. Let me start over again up here. Sorry. Apologize. I was doing too much algebra. Over algebrating. So let's start with n minus g over g is equal to x over 100. I really want to keep that x over 100 in place. So I really only want to multiply both sides by g. So multiply both sides by g. Okay. They cancel out on the left. So all you're left with is n minus g is equal to, I'm going to reverse the order, g times x over 100. G times x over 100. Now I could solve for g, but what I'm really going to do is solve for n. But solving for n will help me solve for g in a weird way. So I'm going to solve for n. So I need to move that g, the minus g. So if I move minus g to the other side, it becomes plus g. So this becomes n equals g plus g times x over 100.
You move the G over there.
I just added g to both sides.
Oh,
Add g, add g. Now, I can't combine these the way they look, so I'm just writing them next to each other. The first one plus the second one. Little more algebra technique. What's 2x plus 3x?
5x.
Why?
Because
Common
It's the same value.
Common denominator. No.
Same variable.
Like
yeah.
terms, same variables. All right. ax plus bx equals
two.
ABX.
ABX,
hold on. How did you get 5?
2 plus 3. A plus BX
A plus b
times X.
times x. Because literally this one up here was 2 plus 3 times x. It's actually the distributive property. Well, if 2x plus 3x is 5x, the 5 comes from adding the first one coefficient plus the second coefficient. So if you have ax plus bx, then the answer is going to be the first coefficient plus the second coefficient times x. So here I have a common variable, g. So what I can do with the g is kind of kick it out, put it outside of parentheses. So you get something that looks like this. N equals, kick out grandma, the coefficients are going to be left inside the parentheses. What's the coefficient of the first g? 1. What's the coefficient of the second g? Oh, sure, here, but the coefficient is any number that's next to it, which is
GX.
x over 100. It's the thing next to g. So what's left behind is x over 100. This is grandma's formula. Now, grandma's formula is good for 2 things. I would not use it to find percent change. It's really useless for that idea, because then you'd have to solve for
x, and if you solve for x, you end up back at new minus old over old. So if you're trying to find percent change, new minus old over old is great. If you're trying to find new, this formula is actually better than new minus old, and it's also better than anything you were taught in 8th grade, the way shortcuts are going around the room. This formula works 10 times faster. But it is the only formula that allows you to solve for g. So, can solve for new quicker, but only way to solve for old grandma. It is the only way to solve for the old value. So if you have to back off your tax or back off your discount, this is the only formula that's going to work. You have no other choice. I can't help you if you try to do it a different way. So let's see how
Can
they
you
work.
hold on for a second? Let me copy that.
Yeah, I'm only going to erase this part here. First part. Who's giggling? Good Lord, what are you giggling about? My entertainment for the day. What's in that soda? I have no idea. So let's go back and look at, I don't know. I doubt this is true, but I'm just making it up. The U.S. population increases at 5% per year. What's interesting about that, we'll get into this at the end of the class. If it's 5% per year, that means the population goes up 5% this year. But when it comes to next year, is the absolute change the same as the previous year? No, even though it's the same 5%, you're taking 5% of a bigger population. So that population increase is actually more, even though it's the same 5%. The per year makes it something weird. All right, so let's say this year it stands at, if I remember right, 320 mil. How many next year? So we could set this up with new minus old over old, but then we'd have to go through some algebra to get new by itself. This formula actually works a lot quicker even if you do the shortcut method. So let's set it up. New equals grandma times 1 plus x over 100. Do I know the new value?
320 million, yes.
No.
No. What's 320 million?
No.
Oh, this is
Last year.
last year.
Or this year, and we're talking about next year. So the new we do not know. The population as it stands now is 320 million. Plus, what's x? 5. Now, is it positive 5 or negative 5? That'll determine the sign right here. Sometimes I'll write 1 plus and make a mistake and erase it and change it back to minus. But it's all dependent on what x is equal to. So x here is a 5% per year, but this is known as a increase. If it was a population decrease, I would actually have to say 5% decrease. I would literally have to say 5% per year. Most people understand as an increase, but if it was a decrease, I'd have to actually say decrease. So this would be 5 out of 100. Later on, when we start just changing percents into decimals, a lot of people put 0.05 over 100. If you're going to write it as 0.05, don't write the 100, because this changes it to a decimal. So if you've already changed it to a decimal in your head, just write the decimal. Don't put the 100. Type that in your calculator, get your answer. One step. It's a one-step process. Don't forget the parentheses. Where your shortcut takes 2 steps, this one only takes 1. That's the beauty of it. How many are here next year?
Anybody? 3,000?
I'm in.
I'm like, wow. That would be 3 billion, by the way. 336 million. Yeah, it's not 336 people, it's 336 million people. Wonder how accurate that would be. I'll have to play around with that. Alright, so that's how you can use it to go forwards. So the average US salary decreased by 7%. Last year it was 54,000. Anybody believe me?
No.
Well, it depends on how you look at average. The average salary, remember I said, was around 200,000? But that's only because you have Bill Gates and Warren Buffett pulling the average up. This would be more like the median salary, and it's pretty accurate. I think it's like 48,500 right now. I'm just making up numbers though. So we're doing a percent increase, percent decrease. So new equals grandma, 1 plus x over 100. Do I know the new values, the new salary?
No.
No. I have no clue what the new salary is, so leave it alone. Do I know the old salary? Yeah, 54,000. Multiply that by 1. What goes next? Minus, because of this word right here. So this would be minus 7, right, over 100. Again, if you change it to 0.07, just write 0.07 and be done with it. So all you have to do is type that in your calculator and you find your new salary.
57,780.
Huh?
50,220.
Should go down.
44 and 20.
If you didn't put minus and put plus, yeah, you went up. How much is it? 50?
I got 5222.
50?
50,222 is what I have, but.
222?
I got 20.
I got 22.
I got 20.
I got 22. You gotta be careful of that word.
54,000 times 7.
Alright, so if you start off this year with 54,000 and the percent decreases by 7%, you'll only be making a lousy 50,220 as your
So you can't find,
median
you can't
salary.
just find old.
We can, and that's the beauty. It's the only way to find old. I haven't done that yet. All I did was show you that this is a better way of going forward. If you're going to find the tax on something, boom. If you're finding the sale on something, boom, just use this formula. That way you don't have to overthink it too much.
You said
Oh.
you just find the tax, use the regular one?
No, I'd say use this one. If you're
Oh,
finding a
okay.
percent increase or decrease on something, use this formula. If you're trying to find the percent increase and decrease, you go back to new minus old over old. Everything else should be grandma formula. Even if you want to do it the shortcut method, I still suggest you do grandma.
Did we ever do the problem that he was talking about?
Nope, we're getting to it right now.
Oh, okay.
Ah, my markers are still screwing up. Her. Backwards. The hard one. Well, it's not really hard. It's just that most people, when they try to do it, they try to do it shortcut method, and the shortcut method falls apart. So if we're going to go backwards, I need to do a calculation. Let's say the total cost are you done lose? I want to go back to the original cost. So you get to the register and all they tell you is the total cost, but you're curious what the sum of all your items were before taxes. Okay. So you set it up as new equals grandma 1 plus x over 100.
You know the new.
I know the new. The new is 405. Grandma?
Don't know.
We don't know. That's what we're looking for. One.
Mine. Well, no.
Which one?
Mine.
Mine.
You want to find out what four sales tax is.
It's positive.
But sales tax is positive. Because sales tax takes your price and increases it. Don't be trying to change things in this because you know you're going backwards. The setup should be exactly the same. If you knew what grandma was, this would be automatically
Positive.
positive. So don't change that. That doesn't change. So this is plus, what's the tax? 8%, so it'd be 8 out of 100. So the formula, you don't want to change anything in the formula. The only thing that changes is what number you put in what position. X is positive because sales tax is increasing price. It's not decreasing price. All right, how do I solve for G? Well, I got to figure out what's next to it. What's 1 plus 8 over 100? 1.08, right? G. How do I solve for G? You divide both sides by 1.08. And amazingly, this undoes a tax, dividing by 1 plus the tax. So what's the grandma equal to, or the old original cost? $375. If you try to do it any other way, it will come out wrong. Okay, let's try it on a sale. Clear, let's see. Okay, sale. The sale price after 45% off is $247.50.
Taxes might go way
Ooh, I could do a combination of tax and sale.
No. No.
I'll have to design one. That would be cool. So the sale price after a 45% off is this. How much did this cost before the sale? Wow, it didn't even write any of that. Curse you. Well, they can listen. Okay, so the formula, N equals G parentheses 1 plus X over 100. What do I know? I know the new value. The new value is 247.50. Do I know the old value? No, that's what I'm looking for. G. 1 minus because it's a discount. X is 45 over 100. What's 1 minus 45 over 100? 0.55. So this would be 0.55 G. And to solve for G, divide both sides by 0.55. And G is going to equal 450 bananas. Dollars. So the original cost of the items was $450, but after the sale it becomes $247.50. This formula is really, really nice. It takes you in both directions and both of them very quickly and accurately. That's the more important part. All right, one for you. Yeah, I can make up one. What's common sense?
There's no such thing as-
Ah. Hmm. The number of employed people in the U.S. now is 154 million. This is a negative 3.4% change from last year, also known as a 3.4% decrease. How many were employed last year? Go ahead.